Have you ever wondered why ships float? The answer lies in a principle formulated over 2,000 years ago by a Greek mathematician and inventor named Archimedes. It's known, fittingly, as Archimedes' Principle. Think of it like this. When an object is placed in a fluid, be it water or air, it'll either sink or float. But why? The answer lies in the concept of buoyancy. Archimedes' Principle states that an object submerged in a fluid experiences an upward force, known as buoyant force, that is equal to the weight of the fluid displaced by the object. This is why a steel ship, although heavy, floats in water. The weight of the water it displaces is greater than the weight of the ship itself. But what causes this buoyant force? The answer lies in pressure. The pressure at the bottom of the object is greater than the pressure at the top due to the weight of the fluid above it. This pressure difference creates an upward force on the object, causing it to float. Archimedes' Principle finds applications in a variety of fields. Shipbuilders, for instance, use it to design ships that can safely float in water. Archaeologists use it to lift sunken ships and artifacts from the seabed. Even in the field of aeronautics, this principle is used to design submarines and airships. Here's a simple way to use Archimedes' Principle to determine the density of an object. First, weigh the object in air. This gives you the object's true weight, which includes the weight of the object itself and the weight of the air it displaces. Then, submerge the object completely in water and weigh it again. This is the object's apparent weight, which is less than its true weight, because the buoyant force is counteracting some of the weight of the object. The difference between the object's true weight and its apparent weight is equal to the buoyant force. Divide this buoyant force by the volume of the object, and voila, you have the density of the object. In summary, Archimedes' Principle is a fundamental law of physics that explains why objects float or sink in fluids. It's a simple yet powerful concept that has wide-ranging applications, from explaining the buoyancy of ships to the flight of airplanes. So the next time you see a ship floating effortlessly in the water, remember, it's all thanks to a Greek mathematician and his principle.